Hello, so today we are going to do this problem called Pascal's triangle. So the problem says basically that we have number of rows as input and we want to return the first number of rows of Pascal's triangle. So what is Pascal's triangle? In math, it's a math concept, and it's basically that a number is the sum of two numbers directly above it, as you can see here. So what do we mean by above it? So we can consider these as rows. And for example, this two here is the sum of the one above it and the one just to the right. So just above it to the left, above it to the right. Here, this is going to be 3 because it's 1 plus 2. Here, same thing, 3 because it's 2 plus 1. Here, it's 6 because it's 3 plus 3, 4 because it's 1 plus 3. So you get the idea there. Now, in terms of these numbers on the diagonal here, so you could either consider that each row starts and ends with 1, okay? So that's why we have 1 here, 1 here, 1 here, and 1 here. Or also you could consider using the same definition as this here, where basically we start out with 1 by definition, but you could see that here we have 0, here we have 0, so 0 plus 1, that gives us 1, 1 plus 0, that gives us 1, and same thing here and here, okay? But at the end, you don't want to return these zeros. You want to return only with ones like this here. Okay, so that's the idea. Now let's see how we can solve it. Okay, so how can we solve this? So the easiest solution, of course, is to just say, okay, yeah, sorry, this is not complete. So we have 3, 3, 4, 6, 4. So the easy thing to do is, okay, let's start with row 1, okay? And after that, we can just look at the previous element, right? And sum up, so basically the previous element, and sum up its element at index. So if we are looking at index I, we are looking at filling index I, we can just look at I minus 1 here, and this is I plus 1. Or actually I in the previous row. So this is 0, 1 in the previous row, 0, 1, 2. So we are looking at the sum of the element at index 0 and the one at the element at index 2. So in our result, first we will add 1, okay? And then in the next iteration, we can just go, so how many elements we have? So this is the row, let's say 0, this is row 1, this is row 2. So if we numerate from 0, then this here has 1 element in the middle and then 2 in the boundaries, so it has I minus 1. Here 3, we have 2, so I minus 1 again. And here 4, we have 3, right? So we can use I minus 1. And just for each element, we just use the element is, which is, let's say, row at position maybe j. It's going to be just the previous row, which is the last element from res. So in Python, we can do position minus 1 at position j minus 1, and then we could add position j, right? So very straightforward. We could just go through the rows from 0 to, or actually, so we can start out with only 1 already in res, and we can go through the rows from 1 to number of rows, right? So here number of rows is 5. So in Python we can do a range and we get to num rows minus 1. And for each one of them, we calculate for each index. So this would be, let's say, I or row. And then we calculate for g from 0, right, to, as we said, I minus 1. Actually from 1 to I minus 1. Or you could say 0 to I minus 1. Yeah, whatever you want. And so here we will fill it up with this formula here, okay? So that's the idea, but this is a simple solution. It's mostly just simulating what Pascal's triangle is doing. It's just for each row, we know how many elements we have. We have I minus 1 element besides 1 and 1, and so we can just add 1 at the beginning and at the end, and then for the middle elements, we can just calculate them using this formula. So that's the first solution. It's of num of rows squared because we do 2 loops and each of them can go up to n. Okay, but this is a pretty straightforward solution. A better actually idea is instead of doing this, what we can do instead is, actually, if you look at this, what's happening, let's pick this, for example, to calculate this element. So if we want to calculate this row here, well, we could just take the previous row 1 to 1 2 times. So we take 1 to 1 here, and we take 1 to 1 here, and of course pad with zeros. So the first one, copy, we pad with 0 at the end. Here we pad the end, and then we do the sum, and this will give us 1 3 3 1, and that's exactly what we want here. And so we just add for the first one 0 at the end, the second one 0 at the front, and just sum them up, and that gives us the second row. Because actually, if you think about it, here you can think of this as 0 here, 0 here, 0 here, 0 here, and now it's just 0 plus 1 1, right? 1 plus 1 2, right? So it's just 1 plus 1 2, so it's just the previous row, but you can sum it 2 times and add 0 at the front. If we take a look at the last one as well, here, it's just 1 3 3 1, okay, and then we copy it again, add 0 to the end here, 0 to the end here, and now we get 1 1 4 6, and then 4. So that's exactly what we have. And why this works, because that's exactly what we are doing here. If you take a look at this 3, it's the sum of 1 and 2, so it's 1 2 1 1 2 1, so it's the sum of 1 and 2 here. And this one here is just 1 plus 0, so the previous here. So if we move the second copy to the right, then we will end up adding the previous 2 elements. So this is the solution we can do here. So we can just start with the same way that we did in the solution before, start with 1. And then just for each row, to calculate it, just take the previous row and take 2 copies of it, and add 0 to the end of one of them, 0 to the front of one of them, and sum them up and add that row. So that's pretty straightforward solution there. Now, time complexity for that solution, again, similar to the previous one, we are doing 2 loops essentially, and each of them is the number of rows, so it's of n squared. So n is the input here. Yeah, so let's write this code and make sure it passes our test cases. Okay, so let's write the code that we saw in the overview. So we will start out with res equal to just the first row of 1, and we'll go through the rows. So that will be from 2, or actually from 1 to the number of rows. And one thing to note is that we actually don't need R here. And now what is our row? We said it's just the 2 previous rows, so let's just call this previous row, which is res minus 1. So we take 2 copies of it, one where we add 0 to the end, another one where we add 0 to the front. So yeah, and then we sum these 2 up. And summing them up, well, what we could do is maybe call this list 1, call this list 2. And summing them up, we could either use a for loop, or even easier, we could just use a zip to zip both of them. And now we can just sum them up. So we will have x and y in this zipped list, and we could just take the sum there. Take the sum of that. Alternatively, of course, if you don't want to use zip, you could just say in range of the length of list 1, and then pretty much you just take list 1 at I plus list 2 at I, and sum that up and add it to your row. So if we say like this, actually let's write it like this and then convert to zip later. That would be easier to understand. So we take the row and then we append it, and then at the end we want to add that row to res. And then after the for loop we want to return res. So let's run this. So that seems to be good. If we add the max value here. That works as well if we submit. Okay, so that passes test cases. Now, slight modification that we can do here is we could just say what we want is this, and we could just add that because that's our row. Okay, and we could delete this. Okay, so that seems good. Another thing actually is this is just this. We don't need to create variables for it. And this is just res position the previous row, basically, and this is the previous row as well. And we could actually just make this easier to understand by doing row equal to this. And if we submit the solution, okay, so that passes test cases. Yeah, so that's pretty much it for this problem today. Thanks for watching and see you on the next one. Bye.